Hello, Coach Holmes here, and today we're going to be talking about inscribed angles. All right, so these are a little bit different. These aren't central angles where the angle is in the center. Inscribed angles is an angle that has its vertex on the circle. Okay, so basically, if I draw a picture right here, that right there, where the vertex is on the circle, that's an inscribed angle. Okay, that's an inscribed angle. Now, there's another thing called intercepted angle, an intercepted arc, which is pretty simple because it's the arc between the endpoints of the inscribed angle. So if I look at this, so I'm basically looking at like here. In the red is my intercepted arc. All right, that's what I know what an intercepted arc is. It's in between the inscribed angle that's on the circle. Now, there's a couple of theorems that we need to discuss that has to do with inscribed angles. So for example, the measure theorem inscribed angles, the measure of an inscribed angle is half of the intercepted arc. So for example, if I look at this right here, if the intercepted arc is 50 degrees, then this angle is about 25 degrees. So it's about half. Whatever the arc is, you divide the arc by 2, you get the inscribed angle. And that's how we know that's how we can find inscribed angles. Now if we're trying to find the arc of it, we just got to double the inscribed angle. Now, theorem that has to do with intercepted arc. If two inscribed angles intercepts, I had to make sure what I was reading, intercept, if two inscribed angles intercept congruent arc of the same arc, then the angles are congruent. So basically what it's saying is that I can have a completely different arc. Or let me put that in green so that way y'all can really see it. I can have a completely different inscribed angle in a different location, and it will still be the same measurement. The arc will be the same, the angles will be the same, no matter what. Right? That's what the theorem tells us. So even if we're looking for a different arc or a different angle, if it's the same arc, they're going to be the same measurement. Now, theorem dealing with triangles. The inscribed angle of a triangle states that if inscribed angles intercept congruent, well, I'm sorry, I messed that up. If inscribed angles of a triangle intercepts a semicircle, it's a right angle. So basically, if I look right here, see this little inscribed angle right here? If it happens to intercept a semicircle, that's a right angle. And we'll talk about what we can do with this later on. But I'm stating the fact that this will be a right angle if the inscribed angle intercepts a semicircle. Now, theorems that has to do with quadrilaterals. If a quadrilateral is inscribed, which remember all four sides touches the circle, then opposite angles are supplementary. Okay? So, remember, if a quadrilateral is inscribed, then the opposite angles are supplementary. So that means that these two will be supplementary, as well as these two being supplementary. And if we remember about supplementary angles, they're two angles that add up to 180. Now, I want to be able to find the number angles. So I have 1, 2, 3, 4, and 5. So looking right here, I know that this inscribed angle intercepted ET. So let me do this real quick. So this intercepts ET right here. So I know the arc of ET is 20. Now, what does that mean? Well, if we remember, whatever the arc is, if we divide that by 2, which is 20 divided by 2, which gives us 10. So angle 1 is equal to 10 degrees. Now, what about angle 2? Well, if I look at angle 2, I'm going to make it a different color. Angle 2 happens to intercept HU, which is about 40. So that means 40 divided by 2 is 20. So angle 2 is 20 degrees. Now, angle 3 here happens to be at EN. And that's about 108. We'll divide 108 by 2, we get 54. So angle 3 is 54 degrees. But now, how do we find angle 4? Well, let's look at this real quick. Let's make it purple. Angle 4 is right here, but here's the problem. It's not inscribed. Because it's not an inscribed angle because this vertex is not on the circle. So I can't just figure out what TH is and then just go from there. But I do know that this is 10 and this is 20 and this is 54. So if we have two angles and we're trying to find a third, we can subtract 180 from 54 and 20. And that will give us 106. So angle 4 is 106 degrees. Now the last thing we're going to talk about, now the last angle is angle 5, and I'm going to write it right here. Angle 5 happens to be at E and N. Oh, but looky here. This is at E, N. So we know that EN is 108. Divide that by 2. Let me fix this real quick. I set it up wrong. Here we go. So we know that's 54 degrees. So we found all of our angles. Okay? We found all the angles that we're looking for. So now I want to go to this next problem. So I want to find angle B and N. Okay, so I want to find both angles. Well, first off, we know that this is a right angle because of the triangle theorem. Where if you have an inscribed triangle, an inscribed angle that intercepts a semicircle, you have a right angle. So this makes it a right triangle. So since we know that one angle is 90, the other two adds up to 90 as well. Excuse me. 2x plus 6 plus x plus 9. So I want to be able to combine like terms. So I get 3x plus 15. Subtract 15 from both sides. That gives us about 75 equals 3x. Divide by 3. That tells us that x is 25. Now, is that our answer? No. We got to be able to plug them in. So if I plug in angle B, that gives me 2x plus 6, which in retrospect, we can say 2 times 25 plus 6. 2 times 25 is 50, plus 6 is about 56 degrees. Now, angle N is about x plus 9. But again, I just gotta replace x with 25. And that gives me 34, because 25 plus 9 is 34 degrees. So that's angle N, and here's angle B. Okay? So first, we gotta be able to solve for x, and then we'll be able to plug it in. But we gotta know that this is a right angle here. Next, and lastly, we have a quadrilateral. But remember, opposite from each other, they're supplementary. So if I know that this is 87 right here, H is 102, and let me use a different color so that way we can distinguish which one's which. I know that these two are supplementary. So that means for O, that's 180 minus 87. So I subtract the 2. Angle O is 93 degrees. Now to find angle P, and then we put that in blue, since that's what this is. Angle P is 180 degrees minus 102. So angle P is about 78 degrees. So one of the things we got to remember is that with inscribed angles, or with the quadrilateral, if it's inscribed, the opposite angles are supplementary, which adds up to 180. So what biggest thing we got to remember is that with inscribed angles, they're going to be on the circle. They're going to be on the circle. So if you have an inscribed angle on the circle that makes a semicircle, that's about 90 degrees. An inscribed angle is half of the intercepted arc. And an inscribed quadrilateral, the opposite angle will be supplementary. Thank you and have a good day.